Okay, this is 7.5, the other trig functions, and this is another really critical lesson. We're going to talk about the algebraic definitions of your other four trig functions as well as reciprocal relationships, and this gives you a lot of tools for trigonometry. So today's objective will be to find values of the tangent, cotangent, secant, and cosecant functions and to sketch their graphs. Alright, so tangent of theta. Well, what is tangent of theta? Well, again, to get these other four trig functions, what I use are called reciprocal relationships. Right? Here's my key diagram of a circle with a second quadrant right triangle. Alright, and this is the diagram we use to, do a lot of trigonometry here because of those algebraic definitions of sine and cosine. Okay, and remember, sine is what? That's right, it is y over r, and cosine is x over r. Now with these two algebraic definitions, alright, and the reciprocal relationships, we can get an expression for the other four trig functions. So the reciprocal relationships, here they are. Okay, well, tangent of theta equals sine of theta over cosine of theta, or also 1 over cotangent of theta, just in case they gave you cotangent of theta. Now, cotangent of theta is cosine of theta over sine of theta. Or if they gave you tangent of theta already, to get cotangent of theta, I go 1 over tangent of theta. Now secant of theta. Secant of theta is 1 over cosine of theta. And cosecant of theta is 1 over sine of theta. Make sure you have these written down and highlighted, and every time you use them, write them down, and you will have them memorized before you know it. And that's really important, because now look what I can do here. What is tangent of theta? Well, let's use our algebraic definitions. And if tangent is sine over cosine, then tangent of theta would be y over r divided by x over r, and your r's would cancel to give you a y over x. Now obviously we cannot divide by 0, so x cannot equal 0. Tangent is undefined when x equals 0. Now cotangent of theta. Well, again, you could think of it like this now. Cotangent of theta is the reciprocal of tangent of theta, so I could go directly to cotangent of theta then is x over y. Now, but most people have it memorized like this. Cotangent of theta is cosine over sine, so that would be x over r divided by y over r, where your r's would cancel and give you that x over y. And obviously, we cannot divide by 0, so that y cannot equal 0. Okay? Now, secant of theta. Well, secant of theta is 1 over cosine of theta. So 1 over cosine of theta would be the reciprocal of x over r, which is r over x. And obviously, x cannot equal 0. And then cosecant of theta, well, that is the reciprocal of sine of theta. So cosecant of theta is 1 over sine of theta. Alright, so sine of theta, again, is y over r, so cosecant would be r over y. And again, y then cannot equal 0 because we cannot divide by 0. And there you go. Now we not only have an algebraic definition for sine and cosine, but we have an algebraic definition for tangent, cotangent, secant, and cosecant. And that is all 6 of our trig functions right there. Alright, now, find the value of each expression to 4 significant digits. Now, they usually don't tell you to round like this in math. You do this a lot in science, so we're kind of helping out the science department here. So tangent of 203.0 degrees. Okay, well, the first thing you need to do is get out your calculator and make sure that you are in degree mode. So hit the mode button, and right now I'm in radian mode, so I arrow down and over and I highlight degree. Now I'm in degree mode, and there's a tangent button on my calculator, just like there's a cosine and a sine button. So now I'm going to go tangent of 203, I don't need the 0.0, and close that parenthesis, and now that is tangent of 203 degrees. And what do I get? To 4 decimal places. That means on this one I just round to the 4th decimal place, and that would be 0.4245. There you go. Now cotangent of 165 degrees. Now this is why we need our reciprocal relationships, because if you look at your calculator, there is not a cotangent button. All right, but everybody knows that cotangent is 1 over tangent. So cotangent of 165 degrees would be 1 over tangent of 165 degrees. And now we can punch that out directly the way we see it and round to 4 sig digs. So I'm going to go 1 divided by tangent of 165 degrees. Close that parenthesis for the angle. And this one, now 4 sig digs, that -3 is your first digit, and then we've got 0.732, and the digit after the 2 is 0, so I don't have to round up, so I'm going to say -3.732. And there you go. Now notice there's no degree symbol here, so this is radians right there. So we've got to go back to mode and get our calculator back to radian mode. Highlight radian and hit enter, and then let's punch it out. Now again, cosecant, just like cotangent, there's not a cosecant button on your calculator, so you've got to use your reciprocal relationships again, and cosecant is 1 over sine. So that means cosecant of -1 would be 1 over sine of -1, and now we can punch that out directly the way we see it. 1 divided by sine of -1, close that angle in radians, and to 4 sig digs I'm getting -1.188. There you go. Now one more, secant of 11 radians. So we're in the right mode, there's no secant button, but you guys know secant is 1 over cosine, so that's going to be 1 over cosine of 11 radians. All right, and that's approximately. All right, now let's punch it out. 1 divided by cosine of 11 radians. And to 4 sig digs, well, I have a 225, and then I go 0.95. So 4 sig digs, that would be 226.0. Note here, I need that 0.0 for the 4 sig digs. And there you go. So these reciprocal relationships that you saw on the last slide, those are critical if you want to do stuff like cotangent, cosecant, and secant on your calculator. You only have 3 trig function buttons on that calculator. Okay, now, you're going to see a lot of problems that look like this. This is a gem, and this type of stuff is worth a lot of points on your exam. So, if theta is a second quadrant angle, so let's diagram a second quadrant angle. Okay, well, there's my second quadrant right triangle. Now let's put that on the coordinate plane. So this vertice right there would be the origin. Okay, I'm working with the triangle first, it looks like. Okay, that's okay. So here's my second quadrant triangle, all right? And now they're telling me that tangent of theta is -3 over 4. So tangent of theta is, okay, I think I'm going to bring in the coordinate plane now, I'm sure. Well, y over x, there's my definition. And opposite over adjacent, maybe not, okay? So SOHCAHTOA here. Well, tangent is opposite over adjacent. So let's see. The opposite to this acute angle right here would have to be a +3. And there, I finally brought in my coordinate plane right here, and I put my circle on it right there. Now you can see this a little clearer. I should have brought that in a little bit earlier, but that's okay. So again, if tangent is opposite over adjacent, well, picture the acute angle right here, and this is the opposite side, which is positive. So that would have to be a positive 3. All right. And then adjacent, well, this is adjacent to this acute angle right here, and that's an x value. That's a negative 4. And by the way, then this triangle is another Pythagorean triple. 3, 4. The hypotenuse must be 5. So again, I know the x is negative 4, the y is 3, and this hypotenuse, which is the radius of this circle, would have to be a 5, because that's a Pythagorean triple right there. All right, now, with this diagram, this is the key now. I can answer all of these questions very easily with, SOHCAHTOA, but we're going to be more efficient if we use our algebraic definitions. Like cosine of theta is, and what I'm going to do here is I'm going to put not only the algebraic definition, but the reciprocal relationship when it's appropriate. So that diagram, a lot of mileage right there. So cosine of theta is algebraic definition x over r. All right, now just look at your diagram right there. X is negative 4, the radius is 5, that's negative 4/5. Okay, now sine of theta is, well, the algebraic definition is y over r, and the y coordinate of my point there is 3, and the radius is 5, so that's 3/5. Now when I do cotangent, secant, and cosecant, I'm going to go ahead and do my reciprocal relationships as well. So cotangent of theta is going to be 1 over tangent of theta, and I could do this way because they gave me tangent of theta. So let's see if I did. Yeah, 1 over tangent of theta. Well, if tangent of theta is negative 3 over 4, 1 over tangent of theta would be the reciprocal of negative 3 over 4. But before we get there, let's do our algebraic definition too right here. All right, so 1 over tangent of theta. Well, remember, tangent of theta is y over x, so this would have to be x over y. And now I can use my diagram or just my reciprocal of negative 3/4 up here. Let's use the diagram just to practice it. So the x is negative 4, and the y is 3, negative 4 over 3. There you go. And by the way, negative 4 over 3 is the reciprocal of negative 3 over 4. So if I was doing this very problem, I wouldn't have done all that extra stuff here. This is just for teaching, because you guys know tangent of theta and cotangent of theta, those are reciprocals of each other. Cotangent of theta equals 1 over tangent of theta. Okay, secant of theta. Well, the reciprocal relationship, that is 1 over cosine of theta. All right, and since cosine of theta is x over r, 1 over x over r would be r over x. All right, so now algebraic definition, the radius is 5, my x coordinate is negative 4, that'd be negative 5/4. Oh, I love this. And cosecant of theta, well, the reciprocal relationship would be 1 over sine of theta. And since sine of theta is y over r, then the reciprocal of that would be r over y. And again, the radius is still 5. My y coordinate is 3. That would be 5/3. This is the power of the algebraic definitions of sine and cosine right there. It makes you much more efficient. This is a great problem. I would highlight this and make sure you understand it. Okay, now we're going to graph tangent and secant, and then we're done. So tangent of theta. Well, here's how we graph tangent of theta without a calculator. Tangent of theta. All right, let's think about tangent and our reciprocal relationships. Now, isn't tangent sine over cosine? So tangent of theta is sine of theta over cosine of theta. And then I can just do a circle centered at the origin, even at the unit circle here. So tangent of 0 would be, all right, well, here we go. There it is right there. And picture the unit circle here. Okay, 0, and we're probably radians here, I'd say. So 0 radians. Well, sine of 0 radians is 0, and 0 over anything is 0, so tangent of 0 would have to be a 0. By the way, cosine of that 0 radians would be a 1. All right, So when theta equals 0, tangent of 0 is 0, so I'm going to start at the origin. Okay, now, cosine of theta is in my divisor here, right? That's going to cause vertical asymptotes because we cannot divide by 0. So when does cosine have an output of 0? Well, cosine has an output of 0 at pi over 2 because there's no horizontal distance right there. So theta cannot equal pi over 2, but then it's also going to equal 0 at 3 pi over 2 and 5 pi over 2 and 7 pi over 2 and so on and so on. All right, so let's think about this a second. All right, that would be my first discontinuity is at pi over 2, and then if I add any multiple of pi to that, I'm going to have another discontinuity. So that's going to be theta cannot equal pi over 2 plus any multiple of pi. So there's my first vertical asymptote at pi over 2, and then plus my any multiple of pi, n times pi, so that's going to be a pi over 2 plus pi, that would be a 3 pi over 2, a 5 pi over 2, and so on in both directions. So there you go. That's going to give us a great start to this graph right here. Now, sine analysis. Let's picture this now. Let's picture quadrant 1. On the coordinate plane, 0 to pi over 2, that represents quadrant 1 of this unit circle right here. 0 to pi over 2. All right? Now, since tangent is sine over cosine, well, isn't sine positive in quadrant 1? And isn't cosine also positive in quadrant 1? So that's going to be a plus. And with this point and this vertical asymptote, this curve can only do one thing. It's going to approach the vertical asymptote, but never get there. It's just going to increase approaching infinity. So there you go. Now let's do the sine analysis on the other side. So we're going from 0 to negative pi over 2, which is quadrant 4 right here. Okay? And now, again, sine is negative in quadrant 4, negative, but cosine is positive, so a negative over a positive is negative. So that means here I'm going to start at the origin, and I'm going to work towards the vertical asymptote going down, but never get there. And there is one period of tangent right there. Okay, isn't that great? Now, let's think about sine of theta equal to 0. Well, we know sine of theta equals 0 at 0 and at pi and at, then you just keep adding these multiples of pi. So I'm going to have another 0 right here, and then right here, and the other direction right there, because these are all pi units apart. 0, pi, 2 pi, and so on. 3 pi, and over here is negative pi. All right? Now, periodicity. This graph right here is the first period of tangent, and since tangent is periodic, that pattern is going to repeat in both directions. So periodicity, let's just keep drawing that pattern between your asymptotes. And I draw that just like that. And that, my friends, is the perfect graph of tangent of theta right there. Okay? Now, let's do the same thing with secant of theta. So secant of theta. Okay, notice I set this one up just slightly different. The horizontal axis is theta, the vertical axis is secant of theta. And notice here I put the hash marks of -1 to 1. All right, because we're going to use those. All right, now first thought is, secant of theta, your reciprocal relationship, secant of theta is 1 over cosine of theta. All right, so let's figure out what we're going to get when theta equals 0. Secant of 0 then would be, and there's my unit circle again, and think about 0 right there, 0 radians. Okay, so what's cosine of 0? It is 1. So 1 divided by 1 is 1. So when theta equals 0, secant of 0 is 1. Let's put a point right there. All right. Now let's think once again about we can't divide by 0, so cosine of theta cannot equal 0, which implies theta cannot equal, all right, well, when does cosine equal 0? Add again, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. All right, so let's start with the first asymptote at pi over 2. Let's put that into our diagram. There it is right there. And then if I go to 3 pi over 2, which is, here's the terminal rate for 3 pi over 2. No, there's no horizontal distance, so that's 0, and I can't divide by 0. So that's, again, any multiple of pi, plus any multiple of pi. So let's go pi over 2, and then let's go 3 pi over 2, 5 pi over 2, and go in both directions. And there you have it. Okay, now I think we could probably do a sine analysis again. Yeah, let's do that. So let's check out quadrant 1 from 0 to pi over 2. All right, first quadrant of the unit circle right here. All right, so cosine is always positive in quadrant 1. So that means secant would be 1 over a positive number, which is positive. So I've got to start from 1 and then work towards that vertical asymptote just like that. Okay, now let's check out 0 to negative pi over 2, which is quadrant 4. Cosine is still positive in quadrant 4. So now I'm going to work to the left towards the vertical asymptote and go up. There you go. All right. Now that's not quite one period of secant right there, but let me give you a little trick on graphing secant. Okay, secant is 1 over cosine of theta, so I use cosine of theta. All right, so secant of n pi. All right, now here's what I'm thinking, right? Secant of any multiple of pi. Well, here's what's going to happen. We're 1 here, all right? And then a secant of pi, that would be a negative 1, so we're going to go down here. And then secant of 2 pi, I'd be back up here at 1, and that pattern just keeps continuing. And then I'd be down here. And I could even do this over here too. Let's see if I did. Oh, yes, I did. There you go. There's some key points. And by the way, what I was saying just a second ago, I use cosine of theta for my graph of secant of theta. I use it as a pattern because these points give me actually a scatter plot of a perfect graph of cosine. So think cosine of theta right now, and there's my graph of cosine of theta right there. Isn't that beautiful? And here's what I mean for the pattern. Do you see this secant from negative pi over 2 to pi over 2? Well, we do the same thing over here at theta equals pi, and the same thing over here at 2 pi, and so on. So that pattern continues. So the first period of secant is from this negative pi over 2, all right? And then you want to probably graph this from pi over 2 to 3 pi over 2, and then that pattern just repeats. So my friends, that is the perfect graph of secant right there without a calculator. And if you wanted to graph this on a calculator, you just go radian mode 1 over cosine of theta on your calculator. All right, periodicity. There it is right there. Okay, so look at these are all in red. Now, I want you guys to do page 286, 13, 15, 17, 23A, 24A, 25A, 26C, 27C, and 28C. And those problems are formatted just like test questions. So do these problems well. Get a hold of me if you have any questions. Thanks and have a great day.